Welcome, stargazers, to the Sleepy Astronomer. Tonight we journey far back in time, before cities, before oceans, even before Earth had a moon. As you settle in, take a moment to breathe deeply. Let the worries of the day drift away, like clouds across the night sky. Where in the world are you watching from? Whether you're in a quiet village or a bustling city beneath the same sky, we're connected by the stars. So dim the lights, get cozy, and let's explore a cosmic mystery together. How did Earth get its moon? Imagine a world without the moon. A night sky with no soft silver glow to comfort the darkness. No crescent hanging delicately above the horizon. No full moon casting long shadows through the trees. Just stars, tiny, flickering, scattered across the great black dome of space. Earth, still warm from its fiery birth, spun silently in the void, bathed in sunlight by day and shrouded in deep, endless night. Back then, Earth was a very different place. The surface was not yet calm or cool. It boiled with molten rock and violent eruptions, its crust unstable, constantly shifting and reshaping. Volcanoes poured lava across vast plains. The sky was filled with ash, steam and gas. Thunder rumbled without end. There were no oceans yet, only pools of liquid fire and scattered fragments of rock crashing down from above. Above this young, chaotic planet, there was no moonlight to soften the darkness. The stars were the only lights in the sky, distant and cold, flickering like tiny lighthouses on the shores of infinity. The absence of a moon meant no tides, no gentle pulling of the oceans to and fro. The seas, when they eventually formed, would have been eerily still, with none of the rhythmic breathing that we know today. There were no months, either. No familiar lunar calendar to guide time. The moon has long been a natural clock, its phases measuring the passing weeks. But in these ancient days, time was marked only by the rising and setting of the sun. Days were shorter, spinning by in just a few hours. Earth turned fast, much faster than it does now. The days flew and the nights vanished quickly. Without the moon, the Earth itself was more unstable. Its axis wobbled unpredictably, tilting this way and that. The seasons, if they could be called that, were erratic and harsh. The moon, you see, acts like a steadying hand, keeping Earth's tilt balanced. But in these moonless beginnings, Earth had no such guide. And yet this was a time of beginnings. The building blocks of life were already present, floating in warm waters, clinging to rock, drifting in the air. The Earth was preparing itself, slowly and with unimaginable patience, to become the home we now know. But it was missing something beautiful, something silent, something that would shape its destiny forever. The moon had not yet arrived, but it was coming. And when it did, the entire story of Earth would change. In the vastness of space, about 4.5 billion years ago, Earth was not the calm, blue marble we know today. It was wild, violent, a newborn planet still finding its shape in a chaotic solar system teeming with fire and fury. The sun had only recently ignited, and around it spun a disk of dust, rock, gas, and ice, leftovers from the sun's own formation. From this swirling cloud, the planets were being born. Earth was one of them, slowly growing as gravity pulled together smaller chunks of material, planetesimals and protoplanets, into a larger and larger mass. Each time one of these objects collided with Earth, it released enormous amounts of energy. Some were the size of mountains, others the size of small planets. When they struck, they melted rock, vaporized oceans, and tore open the Earth's crust over and over again. The heat from these collisions, combined with radioactive elements deep within Earth, kept the planet in a molten state. Lava lakes bubbled, volcanoes erupted without end, and great plumes of vapour and smoke poured into the atmosphere, which was thick, toxic, and unbreathable. Space itself was crowded and dangerous. The early solar system was a cosmic shooting gallery. Fragments of rock, some the size of cities, others no bigger than pebbles, whirled through space at incredible speeds. Gravity was the great sculptor, and every planet, including Earth, was shaped by relentless bombardment. The night sky would not have been quiet. Flaming meteors rained down like fireworks, and each impact reshaped the young world again and again. But among these fragments was something special. A rogue traveller. A planetary embryo about the size of Mars. It had formed in a neighbouring orbit near Earth, and had also been growing through collisions of its own. It was made of rock and metal, much like Earth. Scientists would later call this body Theia, named after the Titan goddess in Greek mythology, who was said to be the mother of the moon. Theia's path was set on a slow, spiralling collision course with Earth. The two bodies danced through space, orbiting the sun, coming closer with each pass. And then, one day, their orbits crossed in just the right way, if we can call it right. At just the wrong moment for peace. At just the right moment for transformation. The impact was unlike anything we can truly imagine. It was not a simple crash. It was a cosmic cataclysm. Theia struck Earth at a shallow angle, perhaps 45 degrees, moving at tens of thousands of kilometers per hour. The force of the collision was beyond comprehension. It released more energy than 1 billion nuclear bombs going off at once. A massive chunk of Earth's outer layer was instantly vaporized. Theia itself was torn apart, its core possibly sinking into Earth to join our planet's own. The rest of its body, along with much of Earth's crust, was flung outward into space, creating a vast, glowing ring of molten debris circling the ruined Earth. Everything changed in that moment. Mountains were flattened, oceans boiled away. The atmosphere was scorched and filled with ash. The surface of Earth became an ocean of lava once more. The sky glowed red from the heat of the debris, and day and night were lost in the haze. But from this destruction came something extraordinary. The debris that now surrounded Earth would not remain a ring of chaos forever. Over time, gravity began to pull it together. Slowly, gently, this broken, glowing matter began to unite. What seemed like the end was only the beginning. In the search to understand how our moon came to be, scientists have studied ancient rocks, built computer models, and even looked to the stars for clues. And over time, one theory has risen above the rest, compelling, dramatic, and supported by both evidence and imagination. It's called the giant impact hypothesis, and it paints a picture of creation not through quiet assembly, but through chaos, violence, and extraordinary transformation. The story begins with two worlds, Earth, still young and molten, and Theia, a protoplanet about the size of Mars. Both formed from the same primordial materials circling the Sun, and for millions of years they shared a neighbourhood in the early solar system. Their paths were not immediately destructive. For a long time they coexisted, perhaps even in a delicate orbital balance. But the solar system was not a place of peace. Gravity pulled constantly, nudging, shifting, destabilizing. Slowly, Theia's orbit became more erratic, its trajectory more threatening. Eventually, there was no avoiding it. Theia's path intersected with Earth's, and they collided in what would become one of the most important events in planetary history. This was no ordinary impact. When Theia struck, it didn't simply bounce off or bury itself inside Earth. The angle was just right, and the speed just high enough, that the collision tore through both bodies. In an instant, huge amounts of material were ejected into space. Molten rock, vaporized minerals, shattered fragments of both Earth and Theia were launched outward, forming a brilliant, hot ring of debris that encircled the ruined planet like a burning halo. The energy released in that moment was nearly beyond comprehension. Earth may have tilted on its axis or spun faster. Its outer layers were peeled back like the skin of an orange. Vast quantities of heat and material surged into the sky and beyond, some of it escaping into space entirely, while the rest settled into orbit. The very bones of the planet were shaken. For a while, Earth was surrounded by this glowing ring of debris, a mix of gas, dust, and molten rock. It shone in the sky, a swirling, unstable ring of fire born from the collision. But this ring wasn't static. It was alive with movement. Pieces slammed into one another, fusing together or shattering again. Gravity, that patient sculptor, slowly began its work. Within days, weeks, or perhaps months, no one knows for certain, a single large object began to form. At first it was rough and uneven, a clump of half-molten rock. But as it grew, it became more spherical, more stable. Over time, the object gathered more and more debris from the ring, sweeping it up in a slow, celestial dance. And eventually, the ring disappeared, its mass pulled together to form a new body. That body was the moon. This theory explains many things that other ideas cannot. For one, the moon and Earth are made of incredibly similar materials. Lunar rocks, brought back by astronauts, reveal oxygen isotopes nearly identical to those found on Earth. This suggests a shared history. But there are also subtle differences, clues that the moon came from the outer layers of Earth, not its deep interior, and possibly mixed with material from another planet, Theia. The moon also lacks heavy elements like iron in its core, another sign that it wasn't formed like Earth, from a full mix of inner and outer materials. Instead, it seems to have been made from the crust and mantle, the outer shell of Earth, and the broken remains of Theia, materials more easily thrown into space during a giant impact. Over time, the moon cooled, hardened, and began its slow, steady orbit around the Earth. It started much closer than it is today, so close that it would have looked enormous in the sky, a fiery giant rising and setting with each spin of the planet. The tides would have been enormous, the nights unnaturally bright. Earth and Moon, forever linked by a moment of unimaginable violence. The giant impact. Hypothesis is not just a theory, it is the story of our origins told through the scars of ancient rock and the quiet pull of gravity. It reminds us that from destruction can come beauty, that even the most chaotic beginnings can lead to harmony. And as the moon continues its eternal journey around the earth, it carries with it the memory of that ancient impact, a silent witness to the moment Earth became not just a planet, but a planet with a companion. In the aftermath of the colossal collision between Earth and Theia, the planet was transformed. Its surface boiled with molten rock. Its skies were choked with smoke and vapour. And all around it, stretching thousands of kilometres into space, was a glowing, swirling disk of debris. This was not the quiet elegance of Saturn's rings, frozen and icy. This was violent, hot and chaotic. A blazing halo of molten Earth and shattered Theia circling in a frenzied orbit. The material in this disk was a mixture of silicates, minerals and metal vapour, all launched into orbit by the impact's unimaginable energy. Some of it escaped Earth's gravity entirely, drifting off into the vast emptiness of space. But the rest remained bound by the planet's pull, caught in a gravitational limbo between being pulled back down and flying away forever. This ring, called a circumplanetary disk, was the cradle of the moon. At first, the debris was far too hot and too unstable to take shape. Temperatures in the disk reached thousands of degrees Celsius. Particles slammed into each other, fusing briefly, then shattering again in bursts of heat and force. The entire system glowed, an incandescent reminder of the violence that had created it. But slowly, gradually, the chaos began to calm. As the days turned into weeks, and the weeks into months, the disk began to cool. Radiation carried heat away into space. The smallest particles, now less energetic, began to clump together. Dust grains merged into pebbles, pebbles into rocks, rocks into boulders. And all the while, these pieces were pulled by gravity into tighter orbits, swirling inward like a whirlpool of molten stone. In this dense region of the disk, a single mass began to grow. It didn't form all at once. It may have begun as several clumps, multiple moonlets, orbiting together in a chaotic dance. These moonlets would collide, break apart, and recombine, until eventually only one remained, the proto-moon. This young moon was still glowing, still molten. Its surface was an ocean of magma, what scientists call a magma ocean, churning and bubbling as the heat from its birth continued to escape. The Earth, too, still glowed with molten scars from the impact. And so, for a time, the Earth and Moon both shimmered in space, two burning worlds locked in orbit, facing one another across the darkness. From Earth's surface, if anyone had been there to see it, the moon would have looked enormous. It was much closer than it is today, perhaps only 15 million to 20,000 miles away, compared to the 238,000 miles we know now. It would have filled the sky, dozens of times larger than today's full moon, casting long, eerie shadows across the volcanic landscape below. The gravitational interaction between Earth and this newborn moon was immense. Earth's spin was incredibly fast. One day may have lasted only a few hours. The moon's pull began to slow it down, drawing energy from Earth's rotation and using it to push itself farther and farther away. This is a process called tidal acceleration. Even now, billions of years later, that process continues. The moon is still retreating, slowly, about 3.8 centimeters every year. A pace so slow we don't notice, yet steady enough that over millions of years it adds up. But in those early days, everything moved faster. The moon's orbit was more elliptical. Its gravitational pull stirred the still-forming oceans on Earth, if they had begun to condense yet, into massive tides, possibly hundreds of meters high. These tides may have contributed to mixing and distributing the elements essential for life, shaping the coastline of a young world not yet ready to host living things. The Earth-Moon system was now stabilizing, though still active, still young. The surface of the moon, though slowly cooling, was still being bombarded. The early solar system was filled with debris, leftover rocks and icy bodies from the age of planetary formation. These struck the moon relentlessly, scarring its surface with the craters we still see today. The largest of these impacts formed the moon's Great Basins and Maria, the dark patches that give the moon its familiar face. Meanwhile, the moon's molten surface gradually solidified. Lighter minerals floated to the top, forming a crust. Heavier elements sank into the interior. And over time, volcanic activity within the moon began to shape its landscape. Lava flowed across the lowlands, filling basins and hardening into smooth plains. These are the dark, flat regions that early astronomers once mistook for seas, calling them Maria, Latin for seas. And so, from a disk of destruction, the moon was born, sculpted not by gentle processes, but by the raw forces of collision, gravity, and time. It emerged from the fire not just as a companion to Earth, but as a stabilizer, a clock, and a mirror in the sky. It would go on to influence tides, mark time, inspire mythology, and guide life itself. But in those first moments, it was simply the child of catastrophe, a glowing ember in orbit, circling a wounded world, both of them healing in silence under the watchful eye of the newborn sun. As the chaos of the giant impact slowly settled, and the vast, glowing disk of debris cooled and condensed, a single object began to dominate the skies above Earth. It was rough at first, an uneven clump of rock and metal, still glowing faintly from the heat of its violent birth. But gravity was patient. Over time, this object pulled itself into a more stable, spherical shape. The moon was forming, not in an instant, but over countless days and nights, slowly growing, hardening, and becoming the celestial companion we know today. This was a time of profound transformation. The young moon, newly assembled from the shattered remains of Earth and Theia, was not the quiet, lifeless sphere we now see drifting through the sky. It was a molten world, its surface covered in a vast, churning ocean of magma. The heat from the impact had left it glowing from within, its crust thin and unstable, its core still sorting itself out. Volcanoes erupted continuously, spilling lava across its surface, creating new layers of terrain, and reshaping the landscape over and over again. Earth, too, was still recovering. Its crust was fractured, its oceans not yet fully formed, its atmosphere thick with steam, carbon dioxide, and volcanic gases. But now it had a moon, large, brilliant, and shockingly close. The moon at that time orbited much nearer to Earth than it does today. From the surface, it would have loomed in the sky like a colossal guardian, many times larger and brighter than the moon we now see. Its immense gravitational influence would have stirred Earth's surface and atmosphere in strange, powerful ways. The relationship between Earth and its moon was more than visual. It was deeply physical. The gravity of the moon pulled on Earth's surface, creating massive tides, possibly hundreds of feet tall in the early oceans, once they formed. The back and forth rhythm of these tides churned the planet's young seas, mixing chemicals and heat, helping to create the conditions that would one day support life. But while Earth was dynamic and active, filled with water, storms and potential, the moon was slowly settling into silence. With no atmosphere to shield it, the moon's surface was constantly bombarded by meteors and space debris. Each impact left a mark, craters of every size, some so deep they cracked the moon's crust. Over millions of years, these craters would cover the moon's face, creating the scarred, cratered landscape we now know. Meanwhile, inside the moon, heavier materials began to sink toward the centre. The molten mantle, still fluid from the impact, allowed denser elements like iron and nickel to migrate inward, forming a core. Above that, the lunar mantle began to stabilise, while the outer layers cooled into a thick crust. But even after its surface began to harden, the moon remained geologically active. Ancient volcanoes formed smooth plains, now visible from Earth as the darker regions known as Maria, Latin for seas. Though the moon appeared calm from a distance, this was a period of continuous change. Tectonic forces shifted its surface. Lava seeped from cracks and fissures. The once fiery world was cooling, hardening, and entering a quieter phase of existence. But the bond between Earth and Moon only grew stronger. As the Moon orbited Earth, the two bodies were locked in a gravitational embrace. Earth's rapid spin began to slow, tugged by the pull of the Moon. In return, the Moon began to move outward, inch by inch, spiralling away over millions of years. This subtle dance continues even now. Our days slowly lengthen, and the moon slips farther into space, almost imperceptibly. This slow separation did something extraordinary. It created balance. The moon's gravitational pull began to stabilize the tilt of the Earth's axis. Without the moon, that tilt could have wobbled wildly over time, causing extreme and unpredictable changes in climate. But the moon acted like a cosmic anchor, steadying the seasons, ensuring a more stable environment. And in that stability, life would one day emerge. The moon's birth was not a singular moment, but a long, unfolding process. A journey from fire to stone, from chaos to quiet companionship. It rose from the wreckage of a planetary collision, and, through the slow hand of gravity, became something beautiful, consistent and essential. It's easy to forget, when we look up at the moon today, white, cold, silent, that it was once a glowing, molten sphere, a product of cosmic violence and unthinkable energy. But without that destruction, without the intense heat, the crashing debris, and the sculpting hand of time, it never would have formed at all. And so the moon took shape, silent, watchful, and steady, a constant presence in Earth's sky, a reminder of the past, a stabilizer of the present, a partner in our planet's long and winding journey through the stars. Long ago, after the moon was born from the molten wreckage of Earth and Theia, it began a slow and silent journey away from the world that had helped create it. This movement was not sudden or dramatic. It was gradual, almost imperceptible. But over billions of years, this drifting apart would have profound consequences for both the moon and Earth. It would alter the length of our days, reshape the rhythms of the tides, and influence the evolution of life itself. In those early days, the moon was incredibly close to Earth, possibly just 20,000 to 20,000 miles away. To put that in perspective, that's about 10 times closer than it is today. From the surface of the young Earth, the moon would have appeared enormous in the sky, a glowing orb stretching across the horizon. It would have looked several times larger than today's full moon, and would have cast brilliant, long shadows across the scorched, still forming surface of the planet. Every rise and set would have been an unforgettable celestial event. But this closeness came with consequences. The gravitational interaction between Earth and the moon created what scientists call tidal forces. The moon pulled on the Earth's oceans, creating massive tidal bulges that raced across the young seas. But the Earth wasn't passive in this exchange, it pushed back. As Earth rotated, it dragged the tidal bulge slightly ahead of the moon's orbit. That bulge, in turn, pulled on the moon, giving it a tiny forward nudge. This invisible tug-of-war had two effects. First, it caused Earth's rotation to slow down very slightly. In other words, the days on Earth began to get longer. In the early aftermath of the moon's formation, a single day on Earth may have lasted only 4 or 5 hours. But with every passing millennium, the tides, powered by the moon, acted like a brake, gradually stretching the length of the day. Over billions of years, those short, rapid days evolved into the 24-hour rhythm we now live by. The second effect of this exchange was that the moon began to move away from Earth. That forward nudge, repeated countless times over millions of years, slowly widened the moon's orbit. Even today, this process continues. The moon is currently receding from Earth at a rate of about 3.8 centimeters per year. That's roughly the rate at which your fingernails grow. It seems small, but over geological time, it makes a difference. In fact, by measuring ancient tidal patterns preserved in rocks, scientists can calculate the moon's distance from Earth millions of years ago and confirm that this slow retreat has been happening steadily since the moon's formation. As the moon moved farther away, its visual impact changed too. It became smaller in Earth's sky. The grand, overwhelming orb that once dominated the heavens became the more modest full moon we know today. One day in the very distant future, it will have moved so far that it will no longer be able to completely cover the sun during an eclipse, meaning total solar eclipses, as we experience them now, will cease to exist. Instead, the moon will only be able to partially cover the sun, creating what's known as annular eclipses. But the moon's retreat wasn't just a matter of distance and beauty, it had consequences for the planet below. As Earth's rotation slowed, the climate began to stabilise. Without the chaotic, rapid spinning of its early days, the planet was better able to maintain consistent weather patterns. And as the moon moved farther away, the size of the tides it caused began to decrease. In the early days, tides may have risen hundreds of feet, surging across continents, and then retreating with immense power. These dramatic tides churned the seas, helped circulate heat, and mix the chemical ingredients that would eventually give rise to life. As the moon continued its outward journey, these tidal forces became gentler and more predictable, helping to shape coastal ecosystems and tidal zones, fertile environments where some of the earliest life on Earth likely thrived. These zones, constantly bathed and exposed by the tides, created a dynamic landscape that encouraged adaptation, growth, and evolutionary experimentation. The moon's gradual movement also helped stabilize Earth's axial tilt. Without the moon, Earth's tilt, which is responsible for the seasons, could vary wildly over time, possibly swinging between extreme angles. This would cause massive climate shifts, ice ages, or scorching heat waves, making it harder for life to take hold. But the moon, with its gravitational influence, acts like a stabilizer, keeping Earth's tilt within a relatively narrow range. This consistency has allowed life to evolve and flourish over hundreds of millions of years. And so, the moon's slow departure is not a story of loss, but of balance. It is a quiet and continuous unfolding, a delicate gravitational ballet that has played out over eons. It is the reason we have regular days and nights. It is the cause of our tides, our eclipses, and our seasons. It is part of the deep structure of life on Earth. Even now, as we gaze up at the moon, it is drifting ever so slightly farther away, silent and serene. But with every inch it moves, it leaves behind a legacy. Longer days, calmer tides, and the enduring stability that allowed a once fiery planet to become a world of forests, oceans, and dreams. The moon moves away, but its influence never fades. The moon's quiet presence in the sky belies its powerful influence over life on Earth. An influence most clearly seen in the movement of the oceans. With its steady gravitational pull, the moon orchestrates the rhythm of the tides, a cosmic dance of water that has shaped our planet's coastlines, nurtured ecosystems, and even guided the evolution of life itself. Without the moon, Earth would be a very different world. Quieter, yes, but also far less dynamic and hospitable. Tides are the regular rise and fall of sea levels, caused primarily by the gravitational pull of the moon, and to a lesser extent, the sun. As the moon orbits Earth, its gravity pulls on our planet. This force affects everything on Earth, but it's especially noticeable in the oceans, where water moves freely in response to the moon's influence. The result is a bulge in the ocean on the side of Earth facing the moon, and a matching bulge on the opposite side, caused by the inertia of the water resisting the pull. These bulges are what we experience as high tides. Because Earth rotates on its axis, different parts of the planet pass through these tidal bulges at different times, creating a continuous cycle of rising and falling water. Most coastal areas experience 2 high tides and 2 low tides every 24 hours and 50 minutes. The time it takes for the moon to return to the same position in the sky relative to that location. This tidal rhythm is ancient. Long before humans appeared, the tides were already sculpting the contours of the continents, wearing away cliffs, depositing sand, and creating estuaries and tidal pools. These shifting environments, in turn, became cradles of life. Shallow coastal regions exposed at low tide and submerged at high tide offered life a place to experiment. Organisms had to adapt to conditions that changed not just seasonally or annually, but daily. This constant push and pull between water and land created pressures that helped drive biological complexity. It's likely that the first animals to crawl onto land evolved in these tidal zones. Stranded by the retreating tide, or lured by the promise of new food sources, early aquatic creatures were encouraged, by necessity and opportunity, to develop limbs, lungs, and the ability to survive outside the water. In this way, the moon may have played a subtle yet essential role in the transition from sea to land. Even after life had firmly taken root on land, the tides continued to be essential. For marine animals, especially those that live in intertidal zones, the timing and strength of the tides can mean the difference between life and death. Crabs, mussels, sea stars, and many types of fish rely on tidal movements to feed, breed, and migrate. Some fish use incoming tides to ride into estuaries, where they spawn and raise their young in safer, shallower waters. Others time their entire reproductive cycles to the rhythm of the tides, laying eggs only when the moonlight is right and the tides are at their peak. For humans, tides have long been both a mystery and a guide. Ancient people observed the moon's phases and their connection to the behaviour of the sea. They noticed that during the full and new moons, tides were stronger, what we now call spring tides, while during the first and last quarters, tides were weaker, known as neap tides. These observations were essential for early fishing, navigation, and understanding natural cycles. Many ancient cultures built their calendars around the moon and the tides, understanding that the sea and sky moved together in a slow, powerful rhythm. Even the earliest myths and spiritual traditions often connected the moon with water, emotion, and change. In many cultures, the moon was seen as a feminine force, a guardian of the tides, fertility, and the hidden depths of life. These symbolic associations were not just poetic, they were reflections of real, observable patterns in nature. But what if the moon had never existed? Without its gravitational pull, Earth would still have tides, thanks to the sun, but they would be far weaker, perhaps only 1/3 as strong. The dramatic twice-daily rise and fall of ocean waters would be reduced to gentle ripples. Entire ecosystems built on the rhythm of the tides might never have developed. Evolution would have followed a different path. Coastal life as we know it might not exist. And human culture, shaped so deeply by the sea, the moon, and time, would be vastly altered. The moon's pull extends beyond just oceans. It tugs at Earth's crust too, causing tiny land tides, invisible to the eye, but measurable by instruments. These movements are so small we don't feel them, but they subtly remind us that the moon is constantly interacting with our planet, not just floating above, but actively shaping the very surface we walk on. In modern times, we still depend on the moon's influence. Tides affect shipping, fishing, and coastal management. They power ecosystems and even help regulate Earth's climate by stirring ocean currents, which distribute heat around the planet. And in a future where humans may one day live on the moon, understanding its influence on Earth will become even more important. It connects us not just to nature, but to the larger cosmos. The tides are Earth's great heartbeat, slow, steady, essential, and it is the moon that keeps that heart beating. Every wave that crashes against the shore, every tide that comes in and goes out, is a whisper from the moon, a reminder of its silent, steady presence above. A presence that has shaped our world in ways both visible and invisible, through the pull of gravity and the power of time. If you've ever looked up at the night sky and seen the moon in its various forms, sometimes a slender crescent, sometimes a glowing half, and other times a radiant full circle, you've witnessed one of the most ancient and mesmerizing cycles known to humanity, the phases of the moon. This cycle is not just a visual spectacle, it is a clock, a calendar, a rhythm that has shaped human civilization, guided life, and inspired wonder for thousands of years. The phases of the moon are a result of its orbit around the Earth, and the way sunlight reflects off its surface. The moon itself does not produce any light. What we see shining in the night sky is sunlight, bouncing off the moon and into our eyes. As the moon travels around the Earth, once every 27.3 days, it moves through different positions relative to the Sun and Earth. These changing positions alter how much of the moon's sunlit side we can see from Earth, creating the familiar phases that repeat in a gentle, predictable pattern. The cycle begins with the new moon. At this stage, the moon is positioned between the Earth and the Sun, with its illuminated side facing away from us. From our perspective, the moon appears invisible, lost in the sun's glare during the day, or shrouded in the night's darkness. This phase has long symbolized new beginnings, hidden potential, and quiet reflection. As the moon moves in its orbit, a sliver of its sunlit side begins to emerge. This is the waxing crescent. Delicate and thin, it lingers just above the western horizon after sunset, a subtle promise of light returning. In many cultures, the waxing crescent has been associated with rebirth, intention setting, and the emergence of energy. Next comes the first quarter, when half of the moon's face is illuminated and half is in shadow. This phase is often misunderstood as a half moon, though it is actually a quarter of the way through the lunar cycle. It stands high in the sky at dusk and remains visible well into the night. Symbolically, the first quarter is a time of action, momentum, and decision-making, a turning point between the dreamlike new moon and the illuminating full moon. As the days pass, the moon continues to wax, grow brighter, moving into the waxing gibbous phase. More than half of its face is now lit, casting a soft, full-bodied glow over the landscape. This is a time of building energy, of things coming to fruition, of light pushing back the darkness. Then finally, the moon becomes full. It rises just as the sun sets, bathing the night in silver light. During a full moon, the Earth is between the sun and the moon, allowing us to see the entire sunlit face of our celestial companion. Throughout history, full moons have been moments of awe and power. Ancient farmers planted and harvested by its light. Poets and mystics saw in it a mirror of the soul. Animals too respond to its brilliance, some becoming more active, others falling silent under its watchful gaze. The full moon marks a moment of culmination, clarity, and emotional intensity. But nothing in the universe stands still, and soon the light begins to fade. the moon enters its waning gibbous phase. It remains bright, but now it rises later each night, appearing higher in the early morning sky. Energy begins to settle. The frantic intensity of the full moon gives way to reflection, integration, and rest. As more of the moon disappears from view, we reach the last quarter. Again, half of the moon is visible. This time, the opposite half from the first quarter. It rises in the middle of the night and lingers into the daylight hours. Traditionally, this phase has been seen as a time of release, of letting go, of clearing away what no longer serves us. Finally, the moon becomes a waning crescent, just a thin curve of light in the early morning sky. It whispers of endings, of cycles completing, of the quiet hush before the beginning returns. The moon grows darker with each passing morning until it vanishes once again into the new moon, and the cycle begins anew. This entire journey from new moon to full and back again takes roughly 29.5 days. This is called the synodic month, and it forms the basis of many traditional calendars, including Islamic, Hebrew, and many indigenous timekeeping systems. In fact, the word month itself comes from the word moon. Long before mechanical clocks or digital devices, humans looked to the sky to mark the passage of time, and the moon offered one of the most dependable natural rhythms. But the influence of the moon's phases goes beyond timekeeping. They subtly affect life on Earth. Some studies have suggested that plant growth, animal behaviour, and even human sleep patterns can fluctuate with the moon's cycle. While not all of these effects are fully understood, they hint at a deeper connection between life on Earth and our glowing satellite. Culturally, the phases of the moon have been woven into stories, rituals, and beliefs. In mythology, the waxing moon is often seen as a symbol of youth and growth, the full moon as maturity and power, and the waning moon as age and wisdom. Many ancient civilizations associated the moon with goddesses: Artemis, Selene, Hecate, Chandra, each representing a different aspect of its changing face. Lunar festivals are still celebrated around the world, from Chinese Mid-Autumn Festival to Hindu Karva Chauth, from Jewish Rosh Chodesh to the Islamic sighting of the crescent moon for Ramadan. The phases of the moon remind us that everything in nature moves in cycles, light to dark, growth to rest, beginnings to endings. Nothing is permanent, but everything returns. The moon does not resist its transformation. It simply follows its path, turning its face with grace and silence. Each night, when we look up and see the moon in its current phase, we are witnessing the result of ancient celestial mechanics, a dance of light and shadow that has unfolded every month for over 4 billion years. It is a quiet teacher, a cosmic mirror, and a faithful companion on this spinning world we call home. Long before the age of telescopes and space travel, long before scientists began to unravel the moon's origins through geology and physics, humans looked up at the night sky and wondered. The moon was a mystery, glowing with cold light, changing shape night after night, and rising and setting with a rhythm that seemed to whisper secrets. In a world without electricity or artificial light, the moon was not just a feature of the sky. It was a presence, a force, a companion in the darkness. And into that silence, humanity poured its imagination. Every ancient culture, from every corner of the earth, crafted myths to explain the moon's origin, its phases, its power over the seas and the soul. These stories did not rely on scientific models or laboratory experiments. They were based on observation, intuition, dreams, and the deep need to find meaning in the universe. And though they differ in their details, these lunar myths often touch on common themes: birth from chaos, cycles of life and death, and the eternal dance between light and darkness. In ancient Mesopotamia, one of the world's oldest civilizations, the moon was considered a god, Sin, or Nana, the father of the sun and Venus. He rowed a boat across the sky, bringing light to the night, and measuring time for humanity. His phases marked the passing of months, and his influence was believed to shape fertility, dreams, and destiny. The moon was not an object but a divine being, powerful and alive. The ancient Egyptians also saw the moon as a god, Khonsu, the traveller. He wandered the sky each night, associated with healing, protection, and time. The moon's regular cycle helped the Egyptians track their calendar, and its phases were seen as symbols of transformation and rebirth. In their myths, the moon helped Thoth, the god of wisdom, restore balance to the cosmos. In Greek mythology, the moon had many faces. Selene was the original lunar goddess, driving her silver chariot across the sky each night. Later Artemis, the goddess of the hunt and protector of women, took on lunar qualities as well. The Greeks also saw the moon's changes as deeply connected to the feminine. Its 29.5-day cycle mirrored the menstrual cycle, and so the moon was tied to birth, cycles, and womanhood. Lunar deities were often depicted as gentle yet formidable, nurturing yet mysterious, just like the moon itself. The Romans inherited many of these myths and gave the moon the name Luna. They built temples in her honour and used the lunar calendar to structure religious festivals. Luna was thought to influence not only the tides, but also the emotions and minds of people. A belief that survives today in the word lunatic, rooted in the idea that the full moon could drive people to madness or heightened sensitivity. In Hindu mythology, the moon is called Chandra, a god of beauty and mystery. He rides a chariot drawn by 10 white horses or an antelope, and is considered both a nourisher and a judge. Chandra plays a key role in stories of love, curses, and immortality. In one famous tale, he married all 27 daughters of the cosmic sage Daksha, but loved only one. As punishment for his favoritism, he was cursed to fade away. But after pleas from the gods, the curse was softened. He would still diminish, but he would always return. Thus, the cycle of the moon was explained as a divine act of mercy and consequence. The Chinese tradition offers its own beautiful and enduring myths. One of the most famous is the tale of Chang'e, the moon goddess who drank an elixir of immortality and floated away from Earth, leaving her husband behind. Now she resides on the moon, accompanied by a jade rabbit who pounds medicine with a mortar and pestle. Each mid-autumn festival, families in China and beyond gaze at the moon and tell her story, sharing mooncakes and poems under its glowing light. To them, the moon is a place of longing, separation, and eternal love. In Native American cultures, the moon is also richly woven into myth. Among the Cree people, the moon is the home of a great hunter. the Inuit believed that the moon was a man named Anningen who chased his sister, the sun, across the sky. The Cherokee told stories of a moon maiden who brought light to the earth and visited humans in dreams. In many of these cultures, the moon is more than a symbol. It is a relative, a being, a force that interacts with the earth and its people. Across Africa, the moon has inspired countless legends. The Khoisan people of southern Africa tell of the moon and the hare, where the hare was sent by the moon to deliver a message of eternal life, but altered the message and brought death instead. The tale explains the moon's waxing and waning as a symbol of immortality, while humans must face mortality because of the hare's mistake. In Polynesian cultures, the moon was seen as a place of origin and a realm of spirits. The Maori people of New Zealand speak of Rona, a woman who was taken to the moon after cursing it during a journey. She is said to still live there, holding a gourd of water, visible in the dark markings of the moon's surface. Even in Norse mythology, the moon was personified as Mani, a male figure who drove a chariot through the sky, pursued by a great wolf who would one day catch and devour him during the events of Ragnarok, the end of the world. The moon, like the sun, was caught in a cosmic drama, forever racing through the heavens. These myths, spanning continents and cultures, times and tongues, reflect something deeply human. They show our need to explain what we see, to connect the unknown with familiar symbols, and to weave the moon into the very fabric of our stories. Before science could explain the moon's orbit or its phases, people used story to shape understanding, and in doing so gave the moon a soul. Even today, when we know the physics behind the moon's light and motion, we still feel something magical when we look up at it. The moon continues to inspire poems, art, music and dreams. It is the setting for love stories, the guardian of night travellers, the face that has watched over Earth since long before we learnt to speak its name. And perhaps that is the truest legacy of the moon's mythology. Not that it explains the moon, but that it reveals us. Our awe, our imagination, our need for meaning, our desire to find beauty and belonging in the vast silence of the sky. In the 1960s and 70s, something extraordinary happened. For the first time in human history, we reached beyond our own world and set foot on another. Through the Apollo missions, humanity did what had once only been the domain of myth and dreams. We travelled to the moon. But the most profound discovery wasn't just that we could go there, it was what we brought back. Not gold, not artifacts, but rocks, dust, fragments of a world long hidden from close inspection. And in those rocks, quietly waiting inside their minerals and isotopes, were secrets, clues to a mystery billions of years old. Where did the moon come from between 1969 and 1972? Astronauts collected and returned to Earth over 800 pounds of lunar material from 6 different landing sites. At first glance, the samples were unassuming, grey, dry, pitted with tiny holes from micrometeorite impacts. But when scientists began to analyse them in laboratories, the results were astonishing. These seemingly ordinary rocks told a story that reshaped our understanding of planetary history. The first surprise was just how similar lunar rocks were to Earth rocks. Their chemical composition, particularly the ratios of oxygen isotopes, was nearly identical to rocks from Earth's mantle. This suggested that the Moon and Earth were formed from the same material, or at least from materials that had once been thoroughly mixed. This finding made several earlier moon formation theories far less likely. One of those earlier ideas was that the Moon had formed alongside Earth, coalescing from the same cloud of gas and dust in orbit around the Sun. But if that were the case, the Moon's composition would likely differ significantly from Earth's. It would carry more of the chemical signatures typical of other planetary bodies in the solar system, but it didn't. It looked almost like Earth itself, but not exactly. Another theory had proposed that the Moon was a wandering body, an asteroid or planetesimal captured by Earth's gravity. But again, if that were true, its composition would have been distinct, more like other rocky bodies in the solar system. The Moon, however, didn't look like a captured stranger. It looked like a piece of Earth, yet not quite the same Earth. It lacked certain elements found deep in Earth's core, like iron. It seemed to be made mostly from lighter surface materials, rocky, silicate-rich, but low in dense metals. This supported the idea that the Moon had formed from the outer layers of Earth, not the whole planet, which brought scientists back to a theory once considered too violent, too dramatic, the giant impact hypothesis. The lunar samples provided compelling evidence for this idea. The high-temperature processes required to produce the types of rocks found on the Moon pointed to an origin involving extreme heat, just the kind of heat that would be generated in a planetary-scale collision. In addition, the lunar rocks revealed another oddity. They were incredibly dry. Unlike Earth rocks, which often contain water locked within their mineral structures, the Moon's samples were nearly waterless. This suggested that the material that formed the Moon had been heated to such an extent that all volatile substances, like water, had been driven off into space. Such conditions would not be found in a gentle, gradual formation process. They would require an immense release of energy. Again, a massive impact fit the evidence. And then there were the spherules, tiny glassy beads found in the Moon's soil, created when molten rock is ejected into the air and cools rapidly into droplets. These spherules were plentiful in the lunar regolith, the Moon's dusty surface layer. Their presence indicated that the Moon's surface had once been exposed to intense volcanic activity and high-energy impacts. Another piece of the puzzle pointing toward violent origin. Even more telling were the differences in isotopic ratios of elements like titanium, chromium, and tungsten. These trace elements, studied with increasingly precise instruments, showed patterns that didn't exactly match Earth's surface, but weren't foreign either. They suggested a mixed origin, a fusion of Earth material with something else. A planetary body, something like Theia. The rocks also revealed the timeline of the Moon's formation. Radiometric dating of the oldest lunar samples, particularly the ancient anorthosite rocks from the Moon's highlands, indicated that the Moon solidified about 4.5 billion years ago, not long after Earth itself formed. This aligned perfectly with the theorized timing of the giant impact. And so, piece by piece, the Moon's rocks began to speak. They told of a world that had once been part of another. A world born from heat and destruction. A world that cooled and crystallized slowly, preserving in its silence a record of the earliest days of the solar system. Beyond their scientific value, these lunar rocks offered something more intangible. Perspective. Holding a rock from the Moon was like holding time itself. It was a fragment of history older than any fossil, any mountain, any ocean. These rocks were untouched by weather, by wind, by water. They had been exposed to space for billions of years, bathed in cosmic rays, scarred by tiny meteors, but never changed in the way Earth changes everything. They were a snapshot of the ancient past. Scientists continue to study these rocks, even today, using new tools and technologies to ask new questions. Each analysis refines our understanding, but the core truth remains. The Moon and Earth are inextricably linked. Not by coincidence, not by capture, but by shared origins, by an ancient cataclysmic event that united them forever. The Moon, then, is more than a companion in the sky. It is a relic of Earth's own formation. A mirror, in some ways, of who we are and where we came from. The dust and stones returned from those silent, airless plains are not just lunar. They are a lost chapter of Earth's story, returned to us from the heavens. And all it took was the courage to go there, and the wisdom to listen to what the Moon had to say. As scientists studied the Moon more closely, both through telescopes and with the help of the precious lunar samples brought back by the Apollo missions, they began to notice something curious. For all its similarities to Earth, the Moon was also missing something fundamental: a magnetic heart. Earth, as we know, possesses a powerful magnetic field, an invisible force that surrounds the planet like a protective bubble. It shields us from harmful solar radiation and helps guide everything from animal migrations to the behaviour of our own technology. This magnetic field is generated by a process known as the geodynamo, which occurs in Earth's outer core. Deep beneath our feet, molten iron and nickel swirl and churn due to Earth's rotation and internal heat. These movements generate electric currents, and those currents create a magnetic field, strong, stable, and essential to life as we know it. But when scientists examined the Moon, they found no such field. There was no global magnetic shield, no active dynamo humming deep within its core. It was, in magnetic terms, a quiet and dormant world. And this absence opened up new questions. Why doesn't the Moon have a magnetic field? Did it ever have one? And what does that tell us about the way it formed? To begin answering these questions, scientists turned to the very rocks that had helped unravel the Moon's origin story. Some of these lunar samples, surprisingly, did show signs of having been magnetized at some point in the deep past. This meant that the Moon might once have had a magnetic field. But if it did, it was far weaker than Earth's, and it eventually faded away. Further analysis revealed that these ancient magnetic signatures dated back to about 4.2 to 3.5 billion years ago. That's not long after the Moon is believed to have formed. For a time, perhaps hundreds of millions of years, the Moon may have had a functioning magnetic field, albeit a weak and short-lived one. But unlike Earth's persistent geodynamo, the Moon's magnetic engine seemed to have sputtered out early in its life, and has remained off ever since. So what happened? The answer lies deep inside the Moon's interior, and, just as importantly, in what isn't inside. Unlike Earth, which has a large dynamic iron core capable of staying hot and fluid, the Moon's interior is far smaller, less energetic, and less metallic. The collision that created the Moon is thought to have stripped away much of the dense, iron-rich material that makes up a planet's core. When Theia collided with Earth, The impact likely ejected mostly the lighter outer layers of Earth into space, forming the Moon from silicates and crustal material, not from the heavy metals concentrated in planetary centres. As a result, the Moon's core is small and composed of less iron and nickel. It's believed to be partially molten at best, and its size is too small to sustain the kind of complex convection currents that drive Earth's magnetic dynamo. Without that churning molten metal, there can be no self-sustaining magnetic field. This absence of a magnetic heart has many consequences. For one, the Moon is constantly exposed to the solar wind, a stream of charged particles from the Sun. On Earth, our magnetic field deflects these particles, preventing them from stripping away our atmosphere and bombarding our surface. On the Moon, however, there is no such protection. The solar wind directly impacts the lunar surface, gradually altering the outermost layer of rock and creating a fragile, dusty coating known as the lunar regolith. This constant exposure also contributes to the Moon's stark, weatherless appearance. There is no atmosphere to erode, no wind to smooth the surface, only the slow abrasion of cosmic particles and micrometeorites. Another implication of the Moon's missing magnetic field lies in the preservation of its surface. Earth's crust is always changing, weathering, shifting, erasing history through erosion and tectonic activity. But the Moon, lacking air, water, and a dynamic core, is more like a museum, its surface frozen in time. Ancient impact craters from billions of years ago remain perfectly preserved, offering scientists a glimpse into the earliest days of the solar system. Without a magnetic field, the Moon has become a kind of cosmic archive, storing the story of the solar system in its quiet dust. Still, the mystery deepened when scientists discovered that some regions of the Moon, like parts of the South Pole Aitken Basin and other ancient impact sites, have unusually strong, localized magnetic anomalies. These magnetic hotspots puzzled researchers. How could parts of the Moon still show signs of magnetism when the global field had long since vanished? One theory is that these anomalies were created by massive meteorite impacts, which may have briefly melted parts of the Moon's crust and core, generating temporary magnetic fields. If iron-rich asteroids struck the Moon, the intense heat and pressure could have magnetized nearby rocks, creating pockets of preserved magnetism. These remnants are not evidence of an ongoing geodynamo, but fossil traces of past events, echoes of a Moon that was once more geologically active. The study of the Moon's magnetic history continues to evolve. New lunar missions, including robotic orbiters and future human landings, are equipped with sensitive instruments to map the Moon's magnetic properties in greater detail. Some researchers even proposed that a short-lived dynamo could have existed in the Moon's early years, driven not by convection, but by the wobbling and shaking of the Moon's orbit, its tidal interactions with Earth creating enough friction to stir the liquid core. If true, it would mean that even a small, quiet world like the Moon once had a magnetic heartbeat, however brief. But for now, the Moon remains magnetically silent. Its stillness is part of its character, an ancient airless world without a shield, exposed and enduring, scarred but steady. It drifts through space not with a roar, but with a hush. And in its quietude, it tells a different kind of story, one of endurance, of simplicity, and of a past burned into rock. The moon has no magnetic field to protect it, no internal engine to drive it, but it endures nonetheless. A celestial ghost of fire and stone, still orbiting, still watching, still remembered in every tide, every eclipse, and every gaze turned upward in the night. For many years, scientists debated how Earth and the Moon came to be such close companions in space. Various theories competed to explain the Moon's origin, and one of the earliest and most enduring was the so-called double planet theory. This idea proposed that Earth and the Moon formed together, side by side, from the same swirling disk of dust and gas that surrounded the newborn sun. Like twin siblings emerging from a cosmic womb, they would have grown up together, gravitationally bound from the beginning. At first glance, this theory seemed elegant. After all, Earth and the Moon share a remarkably close relationship. The Moon orbits Earth in near perfect synchrony, always showing the same face, locked in a gravitational embrace. It seems natural to think they might have formed as partners, born in the same place at the same time. But the more scientists looked into the details, the more problems they found. While Earth and the Moon do share some similarities, particularly in the oxygen isotopes that form a kind of chemical fingerprint, their differences turned out to be just as significant. And these differences gradually cast doubt on the double planet theory. One of the biggest discrepancies lies in density. Earth is much denser than the Moon. This is because Earth has a large, metallic core made mostly of iron and nickel, while the Moon's core is much smaller and less rich in heavy metals. If Earth and the Moon had formed together from the same material, scientists reasoned, they would likely have a more similar internal structure, but the Moon seemed to have been formed from lighter, less metallic elements, more like Earth's crust than its core. This led researchers to ask, if the Moon didn't form with Earth as its twin, where did it come from? The double planet theory also couldn't explain the Moon's lack of volatiles. Volatile elements and compounds, such as water, carbon dioxide, and certain gases, are easily lost when material is heated. Lunar rocks brought back by the Apollo missions showed that the Moon was depleted in these volatiles, suggesting it had been formed in an environment of extreme heat. If the Moon had quietly coalesced next to Earth, why would it be missing the ingredients that Earth still retains? Furthermore, the double planet theory failed to explain the Moon's angular momentum, its orbital energy and spin. The Earth-Moon system has a very specific and unusual angular momentum that suggests a massive dynamic event in its past. The calm formation of two bodies side by side wouldn't produce this result. There would need to be something more dramatic, something powerful enough to shake the entire system and fling material into orbit. And so, slowly, the double planet theory faded into the background. It became a stepping stone, an important chapter in our quest for understanding, but not the final answer. It served as a reminder that appearances can be deceiving. The closeness of Earth and the Moon might suggest a common birth, but the evidence in the rocks, the orbit, and the chemistry pointed to a different kind of origin, one rooted not in partnership, but in trauma. In a sense, the double planet idea speaks to a deeper human desire, the hope that we are not alone, that we were born with a companion beside us. The image of Earth and Moon, emerging together from the same cosmic cradle, offers a feeling of symmetry and comfort. But nature, as it turns out, is rarely so tidy. The real story of the moon is one of loss and aftermath. It is a story of pieces torn from Earth's body, flung into space, and drawn back together by gravity's quiet hand. Still, the double planet theory lingers in our imagination. It reminds us that science is not only a collection of facts, but a journey through ideas. Theories are born, tested, and sometimes replaced, not because they were foolish, but because new evidence shines a brighter light. Each theory, even the ones we leave behind, plays a role in deepening our understanding of the universe. And the moon, whether born beside us or from us, remains our steadfast partner in space. It moves through our skies as a witness to Earth's history, a silent presence that began as a stranger but became a companion. Not a twin perhaps, but a piece of us, a child of catastrophe, sculpted by gravity and softened by time. In the end, the double planet theory may not explain the moon's true origin, but it captures something poetic about our relationship with it. The feeling that Earth and moon are forever connected, not just by proximity, but by destiny. They are two worlds, circling each other in the vastness of space, tied together by a bond forged not in creation, but in collision. After the moon formed and settled into orbit around Earth, its presence began to play a subtle but vital role in stabilizing our planet's behavior. One of the most significant ways the moon influences Earth is through its gravitational pull, which affects the tilt of our planet's axis. This tilt, also known as axial tilt or obliquity, is the angle between Earth's rotational axis and the plane of its orbit around the Sun. Currently, this tilt is about 23.5 degrees, and it is responsible for the changing seasons, the warm summers and cold winters that shape life's rhythms. Without the moon's stabilizing influence, Earth's tilt could wobble unpredictably, swinging dramatically over time. Such wild variations in tilt would cause extreme shifts in climate, making some parts of the world unbearably hot for long stretches and others frigid beyond endurance. These chaotic swings could disrupt the delicate balance that life depends on, making it much harder for ecosystems to adapt and thrive. The moon's gravity acts like a cosmic anchor, keeping Earth's tilt steady within a narrow range. By gently tugging on Earth's equatorial bulge, the moon dampens the natural wobbling motion known as precession. This steadying effect has allowed the seasons to remain relatively consistent over millions of years, providing a reliable environment where plants grow, animals migrate, and human civilizations develop agriculture and culture. Moreover, the presence of the moon influences Earth's rotation rate. Early in Earth's history, days were much shorter, lasting only a few hours. Over time, the moon's gravitational pull has slowed Earth's spin, gradually lengthening the day to the familiar 24 hours we experience now. This slowing rotation affects atmospheric circulation and ocean currents, contributing to the stability of Earth's climate system. Without the moon's influence, Earth might experience wildly fluctuating seasons and faster, less predictable days. The stability we take for granted, the steady progression of spring, summer, autumn and winter, might be replaced by chaotic climate swings, making it difficult for life to flourish. Imagining Earth without the moon also means imagining a planet with weaker tides. The sun's gravity creates tides as well, but they are only about 1/3 as strong as those caused by the moon. Without the moon's pull, ocean tides would be much smaller and less frequent. The large, rhythmic rise and fall of the seas shape coastal ecosystems that serve as nurseries for countless species. These intertidal zones teem with life, adapted to the ebb and flow of water, thriving in conditions that challenge them to survive both submerged and exposed. Tides also play an essential role in mixing ocean waters, distributing heat and nutrients around the globe. This mixing drives ocean currents, which regulate climate by transporting warm water from the equator toward the poles and cold water back toward the tropics. The moon's role in powering tides is thus integral to maintaining Earth's climate balance and supporting marine biodiversity. Without the moon, these processes would be disrupted. Coastal habitats would shrink, nutrient cycling would slow, and the ocean's influence on climate would weaken. The evolutionary pathways of many species, including early life forms that depended on tidal pools and estuaries, might never have occurred. Despite its quiet appearance, the moon has shaped life on Earth in profound ways. It is a stabilizer, a pacemaker, and a guardian of environmental rhythms. Its gravitational pull weaves an invisible thread through the tides, the tilt, and the very heartbeat of our planet. For billions of years, the moon has been a silent witness to Earth's story, a steady presence watching the rise and fall of oceans, the shifting of continents, and the unfolding of life's drama. From the ice ages that sculpted landscapes, to the great migrations of animals, to the blossoming of human civilizations, the moon has remained above, constant and unchanging. Its surface bears the scars of countless cosmic encounters, craters and basins formed by ancient impacts, reminders of the solar system's turbulent past. It reflects sunlight back to Earth, lighting the night and guiding travellers and dreamers alike. The moon's steady orbit is a reminder of balance and endurance. While Earth is vibrant and ever-changing, the moon's quiet, predictable journey through the sky symbolises continuity in a universe of constant motion. As we look up on a clear night and see the moon glowing softly, we are gazing upon a companion that has shaped our world in ways both visible and invisible. It is a symbol of connection between past and present, chaos and order, Earth and cosmos. The moon's story is entwined with our own, a narrative of violence transformed into harmony, of destruction giving way to creation. It remains a silent partner, a guardian of time, and a muse for wonder. And so, as the moon continues its slow dance around Earth, drifting ever so slightly farther away each year, it carries with it the history of billions of years, a testament to the power of cosmic forces, the resilience of our planet, and the deep, enduring bond between two worlds spinning together in the vastness of space.